so let's discuss the atomic number in a little bit more detail just to make sure you fully understand it's important. So the atomic number is always going to equal the number of protons. They are the same number. They mean the same thing, okay? The atomic number is equal to the number of protons in that atom. The number is usually in the upper right-hand corner or in the center of your periodic table. It is what is going to identify the atom. So that number is very specific to the element. So for instance, like in the slide says, if I was given the information that I had a nucleus with 6 protons, that atom is going to always be carbon. If I had a nucleus that had 7 protons, that atom is always going to be nitrogen. You can see the elemental symbols, nuclear symbols written there on the slide. Let's take a look at another one. So let's say I had in the nucleus, I had 19 protons, okay? 19 protons. So that is telling me its atomic number is what? Its atomic number is going to be 19. So I find 19 on my periodic table and I get it is potassium, K. So 19 and its mass number is 39. All right. Notice that there was no charge associated with my element coming straight off the periodic table. When you are taking and looking at elements from the periodic table, you are to assume that they are neutral, meaning that there is 0 charge on that atom. The only time that you deal with charges on atoms is when they have undergone a physical change or a chemical change. A chemical change. So that means that unless they have undergone that chemical change, they are going to have a neutral or 0 charge. Okay, it's the electrons that react in a chemical reaction, and when they react, they are going to be moving from one atom to another, and that is where we get those charged particles. Or we can go in and we can physically charge them ourselves by manipulating the electrons. So unless they physically tell you in a problem that you're dealing with a charged particle, you are going to assume that that element is neutral.